Have you ever seen how shiny gold plating is added to jewelry, or how batteries use liquids to store power? Let's find out the answers to these questions in this video of Class 8 on the chapter Chemical Effects of Electric Current. Let's quickly review what conduction of electricity means and how it works. Conduction of electricity is the movement of electrically charged particles like electrons or ions through a material. This movement creates an electric current. Materials can be categorized into two types based on their ability to allow electrically charged particles to pass. First type is conductors. Conductor. Substances that allow electricity to pass through them are called conductors. These materials have free electrons or ions that enable the flow of electric current. For example, metals like copper and aluminum, which are good conductors, are used for electrical wires and circuits. Second type is insulators. Insulators, substances that do not allow electricity to pass through them, are called insulators. These materials lack free electrons or ions, which prevents the flow of electric current. For example, rubber is used in gloves to protect individuals from electric shocks. Plastic is commonly used as coverings for electrical wires and switches. Now that we know about conductors and insulators, let's find out if liquids can conduct electricity. The answer is yes, many liquids can conduct electricity because they contain free ions. Let us see how we can test the liquids for conduction. Tester setup. To test if a liquid conducts electricity, use a tester. Check if the tester works by connecting its free ends temporarily to complete the circuit. If the bulb glows, the tester works. If not, check for loose connections, a fused bulb, or dead cells. Testing liquids. Pour a teaspoon of lemon juice, vinegar, or other liquids in the beaker. Dip the ends of the tester into the liquid, ensuring they are about 1 centimeters apart. If the bulb glows, the liquid conducts electricity. If the bulb doesn't glow, the current is too weak, or the liquid is a poor conductor. LED as indicator. Use an LED instead of a bulb. LEDs glow even with weak currents. LEDs can detect even a small flow of electricity through a liquid, making it easier to see if the liquid conducts electricity. So, students, liquids like acidic solution, salt water, lemon juice, tap water, milk, and vinegar are good examples of liquid conducting electricity as they have free ions. These liquids allow electricity to pass through them as the LED bulb glowed in their case. Some liquids like distilled water, oil, and kerosene don't conduct electricity because they do not have free electrons or ions. Let us see the effect of salt in water. Water with salt dissolved in them can carry electricity. We can check this by this experiment using two electrodes and a light bulb. But first of all, let us understand what are electrodes. Electrodes are conducting materials through which current enters or leaves a substance. There are two types of electrodes, positive electrode and negative electrode. Positive electrode, it is the electrode which is connected to the positive terminal of the battery. It is also known as anode. Negative electrode, it is the electrode which is connected to the negative terminal of the battery. It is also known as cathode. So, when electric current is passed through a salty water, some chemical reaction takes place. This is known as chemical effects of electric current. So, what can we observe from this? Salts dissolved in water are responsible for conduction of electricity through water. Tap water, acid solutions, basic solutions, etc. are good conductors of electricity. Distilled water is poor conductor of electricity because no salt is present in distilled water. Examples of chemical effects of electric current. When electric current is passed through water, water dissociates into hydrogen and oxygen. Hydrogen is deposited over negative pole and oxygen is deposited over positive pole. When electric current is passed through the solution of a metal salt, such as solution of copper sulfate, metal gets deposited at the negative pole because metal is positively charged. Let us now learn about electroplating. Electroplating is one of the chemical effects of electric current. Electroplating is a chemical process using which a metal is coated with a layer of another desired metal. Electroplating is done to prevent iron from getting rusted. A metal salt solution is taken in a container. The salt of the metal is chosen, which is to be coated over another metal. The metal which is to be coated is dipped in the solution and connected with the negative pole. The metal for the desired coating is connected with the positive pole. When electric current is passed through the solution, the metal from the anode is dissolved in the salt solution and deposited over the negative pole or cathode. Thus, a coating of the desired metal is obtained on another metal. Here are the uses of electroplating. Water pipes made of iron are coated with a layer of zinc metal by electroplating. Zinc is less reactive than iron and prevents the iron pipe from getting rusted. Rims of wheels of cycles, cars, etc. are electroplated with chromium metal. The layer of chromium metal gives them a shiny appearance and prevents rust. Ornaments made of silver or other cheap metals are electroplated with gold to give them the appearance of gold.
We hope that you've understood the topic. You can now study chapter notes, watch video lectures, and solve MCQ test of this chapter on EduRev to ensure you score well in your school exams. And that's not all. You also get amazing courses for maths, science, English, Hindi, and much more for class 8. Thank you.